Okay. So, people, I believe you can all see the warm-up. So for item number 1 there, I have the first 3 digits to start off some kind of sequence. And what I would like you to do is that, with the knowledge that this is the first term, the second term, the third term, go ahead and determine the 131st term. And then for item number 2, I have another sequence, -6, -3, -2, -3 over 2. Go ahead and try and figure out what the explicit formula is for that particular sequence. And then we will go over these 2 items. I guess first things first, just some information real quick about the shape of the week. We have notes today, and I actually think the next 2 sections of notes are pretty straightforward, because instead of the first section of this chapter where we talk about sequence in like generalities, we just kind of throw all of the possible questions together into one big bowl. The next 2 sections are going to take a very specific look at 2 specific types of important sequences, and we're going to develop some terminology that are specific to those classifications of sequences, as well as like recipes to deal with the questions that we could reasonably deal with in those within those categories. So that'll be notes today, workshop tomorrow, notes on Wednesday, and then on Thursday there's no class. I just want everybody to know that right now, that on Thursday you will have no class whatsoever. So you'll have 2 days for the homework that will start on Wednesday, and then Friday will just be workshop for that same section. And the reason why there's no class on Thursday is that I have a comprehensive exam that day. If school wasn't canceled, you guys would just have a sub that day and probably be watching a YouTube video or something anyway. So since we're all at home, I'm just going to give you guys the day off. But that day I'll be taking a test from 10 a.m. to 6 p.m. And I just don't want to teach in the morning for an hour and then stop and then go take a test for the rest of the day. You know what I'm saying? So I'm just going to cancel all my classes Thursday. Is that okay? Does that make sense? Anybody out there?
Yeah, it makes sense.
Oh, okay, just making sure, because I switched my headphones and I just wanted to make sure that the settings didn't get jacked up in the swap. Okay, so in the meantime then, while y'all get a chance to take a crack at the warm-up, let me go ahead and talk about so many papers, the Chapter 9 test. So I guess this is old news just because this is how the this is how I graded the other 2 assessments that we've done since we've been take from home. I have a lot of y'all to make comments on your work, and I have no super great way to make comments on that work. Like I don't have a tablet or whatever where I can grade your guys' tests up like normal. So what I do is I have the key open, and then I have a grading sheet for the class. And as I grade your test, I go down from the top to the bottom, and I keep track of how many points you scored on each question, and then in the end, I add it up. If we were having issues, I would go through and be more explicit with my grading comments. But with the average being what it was, the average was like a middle A. I figure most of y'all are pretty confident in your matrix skills, especially since you guys told me it was review. It was pretty obvious that you guys have done this before based on what I graded on the test. Good work all around, especially on the symbolic questions, the ones where not everything was a number. Yeah, anyway, if you would like your personal breakdown of your score on the test, just shoot me an email and just ask for a Chapter 9 test grade breakdown, and it'll take me like a second to just, you know, quickly type out what you got for each question, so you know where you got complete credit and where you got partial credit. But nonetheless, the solution key to that test is posted. The work's not the best because it's just like my own scratch work to generate the key. I just wanted y'all to have access to the answers and the point values without me having to read all that stuff out from top to bottom. So before we get started, are there any questions from the chapter test or about its grading?
Nope, I don't think so.
No? Okay, yeah, it was pretty straightforward. So I'll just take the chapter 9 test key and file it away. I think that's about it. Also, the other thing I want to clue you guys into is, did you guys read the email that went out on Friday? I believe the school, the email is titled Seniors in the Spotlight. Go ahead and find that email and read it.
I don't see it.
Yeah, same.
You guys?
I don't think they sent it to us.
Oh, okay. Never mind then. If the contents of that email are relevant to you, I guess I'll know before the end of the week after our start of the month teacher meeting. So I'll probably have news to fill y'all in on by the end of the week. Nonetheless, let's go ahead and get started today with this warm-up so that we can get into the notes and have hopefully be done before too long. Could I have some assistance? What type of sequence does it seem like item number 1 is?
Geometric.
Geometric means that it gets multiplied by the same number every step. So 2, 4, 8, 16, 32, 64, 128 is a geometric sequence by factor of 2. I don't think this one's geometric. We don't seem to be multiplying here.
Oh, then it's arithmetic, right?
Sure. And the way that we figure out it's arithmetic is by doing what?
Adding 200 to negative 28, and then each time you're adding 200.
Well, the thing that gives away the fact that it is arithmetic is the fact that the difference between both of these numbers, right? Just subtract them to find the difference. That amount is the same, and yeah, it's going up by 200. So these are the first 3 digits, which means that we have to add 200, 120 more, or sorry, 129 more times in order to get the 131st term, right? That's how we do that. That's the only way to get the 131st term. True, false? Is there another way to do it? Do I actually have to add 130 or add 200 131 times?
No, you can multiply.
Right. Multiplication is just a lot of addition in aggregate, right? Instead of adding 10 times, we can just add 100. So we could either realize that right here, whatever this sequence is, let's just call it A, that this is A3. So if I want to get to the 131st position, then we're going to have to add the common difference how many more times?
$131.
128 more times.
128 more times. So we could get there by taking this term and then adding 128 times 200. The thing that I'm more preferential to, and this is what I recommend if you're asked to find some like far down the line term in a sequence, just figure out the explicit equation if it's possible, and then plug the desired n value into that explicit equation. So let's go ahead and come up with the explicit equation for the sequence and then plug in 131. So this is A1, this is A2, this is A3. This is to say that we're working within some sort of sequence A sub n, which is equal to what? What was my common difference?
200.
Right, so that's going to be 200n, right? Because the common difference acts a lot like the slope of a linear equation. And then in order to tune in the way that this sequence behaves, we're also going to have to add a constant. And so how can I add in that constant? How can I determine what that is?
I guess how much it's shifted from 0, so like minus 28, because that's how far back it is, I guess.
So no, and this is the same about solving for the intercept of a linear equation. Once you have the slope, the way that you solve for the intercept of a linear equation is that you plug in a point. If you were to just say that the constant is negative 28 because it's the first digit, you would be misaligning one of your points. What number are we plugging in when we generate negative 28? Which term is this?
1.
This is the first term. So the act of plugging in a point is going to look like this in this line. If we plug in a 1, we're actually saying negative 28 is equal to 200 times 1, because that's our first term, then plus b. And so what is b? B is equal to?
172.
Negative 228.
Negative 228. This is to say that our sequence generator is going to be equal here to 200n minus 228. So this captures both our common difference and the constant needed to get the correct first term in the sequence. And so getting the 131st term makes this as simple as substitution. A sub 131 is going to be equal to 200 times 131 minus 228, which is going to be equal to whatever our answer is, 200 times 131 minus 228, 25,972. Let me finish taking attendance, and then we'll do the second one. Okay. Yeah, so any questions on this first one? No? Okay. Item number 2, write me an explicit formula that generates the sequence. Was anybody able to figure out anything clever?
I put -1 times 6 over n.
That is correct. So let's just go ahead and start off by recognizing the pattern that's going on here, right? So first thing is, I know it's not linear. It can't be linear. If it was linear, it would have a common difference, and we're going from -6 to -3 to -2. Here to here, that's a change of -3. Here to here, that's a change of 1. And then here to here, our change gets into fractions, which is a good indicator that it's not linear. We'll have to then try some other type of relationship. And so here's what I think is a good approach, right? Recognize that this is A1, recognize that this is A2, recognize that this is A3, A4. And just like trying to figure out any other equation, I think it's a little bit easier to see if we write like an XY chart or some sort of input-output. So in each case here, we're putting in an n and we're getting out an a sub n. So when I put in 1, I get back -6. When I put in 2, I get back -3. When I put in 3, I get back -2. When I put in 4, I get back -3 over 2. And so I guess kind of the giveaway here is that this is, you put in 1, you get back -6. You put in 2, you get back -3, right? 6 divided by 2 is 3. And after we see that little bit of intuition in the first entry, the rest of it happens to have the same pattern. 6 divided by 3 is -2. 6 divided by 4 is -3/2. So if the thing that's generating this is that it's -6 divided by the term that it is in the sequence, we have a lot of ways that we could write that, which is why when it comes to these sequences, technically there's an infinite number of correct answers, because I could say that this is equal to just -6/n. That's actually sufficient to give us the value in every entry. This could also be written as -1 times 6/n, where we're processing the 6/n first, or this could also equally be written as -12/2 times n, or what have you. So I think -6/n is the most succinct way to write this particular sequence. There are technically an infinite number of alternate answers. Anything which would give back the same sequence is technically correct. Any questions here? Is this okay for item 2? Okay. So just so you know, today's notes are probably going to be a little straightforward, just because, like I said, we're going to take and we're going to drill down on one particular topic. Today we're talking about section 11.2. Today we're going to take a more detailed look at arithmetic sequences. And the reason why we are taking such a close look at such a straightforward sequence is that later on in this chapter we'll be doing a slightly different skill from sequences called series, and there we'll see that arithmetic sequences have a very interesting property when utilized as a series. Nonetheless, an arithmetic sequence, which is what we're talking about today, is a sequence of numeric terms generated by a linear relationship. And so this is to say that as our numbers go along, right? So if we were to have some a, which was equal to a 1 plus, I'm sorry, not plus, a 1 comma a2, getting ahead of myself, a 1 comma a 2 comma a 3 comma a 4 dot dot dot, then the points that play out here are going to follow a linear relationship, like a linear equation. So when you have a linear equation, right, the object itself is growing according to the slope relationship. Y is equal to mx plus b. So every time you step forward one step in the x direction, you're going to go up or you're going to go down by the amount that is dictated then by the slope. Now, the reason why we need the slope to talk about linear relationships, right, you have m is equal to y minus y divided by x minus x, is that when you're taking steps forward through a linear equation, the step that you take forward in the x direction every time is whatever size you dictate it to be. So you could calculate the slope out over a total change of 1,000 units in the x direction, or you could calculate the slope out over a change in 1/1,000,000th of a step in the x direction. However, here with sequences, we don't need to have the same fidelity of information in order to clearly define this relationship, because it steps forward by 1 every single time. So when we talk about the slope here, right, and keep in mind that it's not technically the slope because this isn't the same type of relationship, but the thing that acts as the slope in this type of sequence, right? So if I said m was equal to the change in the output divided by the change in the input, well, our slope here, our outputs are going to be these a's. And then down below, every time we take a step forward through our inputs, we're just adding 1. So A1 is what I get when I plug in 1, A2 is what I get when I plug in 2, A3 is what I get when I plug in 3. So down here in the denominator, right, since we always step forward by 1, this is just going to be n plus 1, then minus n. What is n plus 1 minus n? N plus 1 minus n?
1.
That's
There
just
should
1.
be 1.
N minus n is 0. So the thing that is acting as our slope here is just a times n plus 1 minus a sub n, then divided by 1. which is going to be equal to a sub n plus 1 minus a sub n. So instead of using the slope, right, since we're always taking the same step forward, you don't actually need to be that detailed about this information. Since we're always stepping forward by units of 1, then the thing which is generating this, we can just call our common difference. Instead of slope, the thing that plays the same role in the explicit equation, we just call this b. This is our common difference. So you know that you're looking at an arithmetic equation because as we go from here to here to here to here, as we step forward each time, we are always adding the exact same constant from every step. So plus b, plus b, plus b. And so when it comes to the writing of this type of arithmetic sequence, we have two options, right? Same as our options before. We could either write this out as an explicit arithmetic sequence, or we can write it as a recursive arithmetic sequence. So when we write it as an explicit arithmetic sequence, like I said, this is growing linearly. So this is more or less going to have a the appearance of a linear equation. And I super regret using b for my common difference just now, because we're going to use that for something else in a second. I'm sorry if this is like inconvenient to change your notes. This should be a d if we want it to match the book. Or if you don't care, you can switch the variables and keep them switched. Common difference d plus d plus d plus d. My apologies. Nonetheless, when it comes to writing the explicit equation, this is a lot like working with linear equations. So it's just going to be a is equal to n times d. So n, the number that we are plugging in, the distance along that we are in our sequence, then multiplied by the common sequence, plus a linear equation constant, b. So this is exactly the same as the linear equation, y is equal to mx plus b, except instead of talking about points along a line, we're talking about elements along an arithmetic sequence. And so typically what we do here is that after establishing that our common difference is d, you set up the equation and then plug in one value to solve for b. So if you have your first entry and your common difference, you plug those in order to solve for the constant b, which will fix the rest of your sequence. Yeah. Okay, anyway, and then the recursive formula that we have for our arithmetic sequence is also pretty straightforward, right? So the recursive formula for our sequence for this type, for this arithmetic sequence is generated by the fact that we're adding the exact same digit every single time, one after the other. So our recursive formula is a to the n plus 1. To get the next number in a sequence, you take the previous sequence, a sub n, and then to that you add the common difference b. For this one, there's typically no real solving to do. Just keep in mind that for the recursive formula to work out, you also have to provide information about one of the terms in your sequence. So you would have to give this plus one term. So you need to provide, a sub n plus 1 is equal to a to the n plus r, the common difference d. You must also provide one term in the sequence in order to well define it. Typically the first term. Yeah. Okay. Are there any questions here? This is about it for notes. We're going to do 2 example questions and then talk about one important concept. But more or less, an arithmetic sequence is a sequence generated by a linear equation. We have a thing which plays the role of slope. We have a thing which plays the role of our constant. So, for example, let's say that we have the arithmetic sequence 1200. Yeah. So for example, we have 1200, comma, 1150. And let's just say that I'm going to tell you that this is an arithmetic sequence. Normally, 2 digits wouldn't be enough to establish an equation. Normally, if I gave you 2 digits, it would be ambiguous whether or not this was decreasing by subtraction, or maybe we're doing it by some weird multiplicative factor, or maybe some more exotic function. So if I give you 2 digits, this isn't enough to establish that this is arithmetic. I could say on the side, hey, this is an arithmetic sequence, do the rest of this problem. Or the other way that we could be confident that this is arithmetic is by being provided a 3rd digit, which in this case would have to be 1100 in order for this to be arithmetic. But nonetheless, let's just do all possible tasks with this. So number 1, we want to write the recursive formula. We also want to then write the explicit form. And then we also want to generate the 2000th term. So item number 1, what is the recursive form? What is our common difference here?
Minus 50.
Yeah, each time we're just subtracting 50. So this is to say that for our recursive form of the equation, a sub n plus 1, the next term in this sequence, is generated by taking the previous term a sub n, and then from that we will subtract 50 or add negative 50, same thing. And then in order to fix the position of this, because if this first term was 0 and this was all the information we had, then our sequence would read out 0, negative 50, negative 100, da 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 da. To fix where this begins, you must also provide 1 digit. So we could just start this off by saying a sub 1 is equal to 1200. That would be correct. But technically, providing any digit should be sufficient to generate every other term in the sequence. So if you wanted to be fancy and say a sub 2 is equal to 1150, well, this is the exact same data, telling somebody the slope and 1 ordered pair along the line. Is that okay?
Yeah.
Yeah, okay. So now let's go ahead and generate the explicit form of the sequence. So this is to say that instead of saying, hey, get the next term based on the previous term, we could say that, hey, give me any term in here based on n. So this is to say that I'm going to have a sub n is equal to, we'll follow our little recipe. Well, it's going to be n times d, so n multiplied by our common difference, which we just said is negative 50, then plus b. So this is the linear equation that we need to solve for b in order to define what's going on in this sequence. And so let's go ahead and plug in a value. Which value should we plug in?
1200.
Sure, yeah, but again, it doesn't matter. You could plug in any one of these values, either plug in this and 1, this and 2, this and 3. They should all give the same answer. So this is to say we get 1200 is equal to 1 times negative 50 plus b. And so b is equal to 1250. And so our explicit sequence here is that a sub n is equal to negative 50 n plus 1250, and this generates all of the terms in our sequence, which will therefore also let us use it to generate our 2000th term, so that we're not doing this 2000 times, right? Like just minus 50, minus 50, minus 50, minus 50. And so for the final part, a sub 2000 should just be equal to negative 50 times 2000 plus 1250. And so the 2000th term in this sequence, sequence A, should be equal to negative 50 times 2000 plus 1250, which in this case is negative 98,750. And to be real with you, this is what the overwhelming majority of the homework looks like. These particular exercises when solving for the bits and pieces of a arithmetic sequence. Are there any questions here on this example, item 1?
Don't think so. It's pretty easy.
Yeah.
This looks pretty easy.
Yeah, so while the symbols are different, mathematically speaking, this is just more manipulation of linear equations. Now, the only difference that it's important to leave this little lecture here with is that even though the mechanics and the math here of sequences are a lot like linear equations, because like I said, this arithmetic sequence thing, the thing that it's doing is every time we step forward in x, we're gaining the same amount in our output, which is kind of by definition what a linear equation is, where the common difference is playing the role of the slope. I think it's important here to keep in mind that even though they're very similar, they are not by any means identical. And so please just keep in mind the following graph in your brain. That there is an important difference between sequences and regular old X, Y input-output functions. And the reason why I bring this up is twofold. Number one, I'm going to ask something conceptual about this on the quiz, and that phrase tends to wake everybody up. And number two, at the beginning of the homework, there are always 4 concept questions, 4 or 5 for this chapter. And this right here is the answer to one of those homework questions. So I want to compare and contrast the function y is equal to 2x plus 1 versus the arithmetic sequence a sub n is equal to 2n plus 1. So what's similar about these? What's different about them? Let's start off with a similarity. How are they similar?
They all follow the same path, I guess. Like all the same points, kind of.
So,
but one's just values, one's like a complete line.
good. So one of these will only generate values. The other one is a complete line, which has implications for the way that we think about it, the way that we graph it, and the way that an inverse would behave when performed on one of these functions. So the way that I like to think about it is that all of these points are here, but not all of these points are here. So if we were to graph these in their respective variables, this first one is x versus y, and this is telling us to do the 6th grade thing. And first we find the y-intercept, which is 1, and then we get another point using the slope. So I go up to 1, 2, over 1, over 1. And so this right here is one of the points. And then once I have these 2 points, I can connect these two with a solid line. Over here, when it comes to graphing the values of the arithmetic sequence, we have to be very precise because of the rules of an arithmetic sequence. There is no 0th term because of the way that I've laid this out. We always start at 1 by tradition. So here, the first value that actually exists, I would have to go over to 1. I would have to plug in 1, which is going to be 2 times 1 plus 1, which is 3. 1, 2, 3. And so this right here is my A1, our very first point. A1, which is equal to 3. This point here is to say A1 is equal to 3. Here, this would just be the ordered pair 1, 3. And then as I go along, I can use the common difference in order to generate the rest, right? I go up 2, just like the slope, up 1, 2 over 1. Up 2, 1, 2 over 1. Up 2, 1, 2 over 1. And so while all of these points trace out the same pathway that this line would trace out, here, what's in between these points? What is right there?
Nothing. Yes.
There is nothing here. And in between, once again, there is nothing here. And so if you were asked what is some A sub 1.5, that's not well defined at all. You couldn't write that down. Whereas here, when it comes to a linear equation, I can literally plug in any value I want to generate any possible value along the line. So they have similar mechanics, but technically their domains, ranges are defined differently. Their inverses are defined very, very differently. And hey, that's it for arithmetic sequences. All I have is a homework assignment where we'll do some exercises generating them out, trying to figure out what they are in a couple different cases. But I think this section is pretty straightforward, and so is the next one, which we'll be going over on Wednesday. Are there any questions on that stuff or about the class in general? Is the pathway to the end of the year pretty clear?
Yeah.
Yep.
Yeah. Also, on that last question on the homework, I'm sorry, not the last question on the homework, the bonus question on the test where I just asked you guys about like, hey, what's going on next year? It sounds like most of y'all are going to Messerobian. Is that the plan?
I guess for other people, yeah.
Yeah.
Yeah, for a bunch of y'all that sounded like it was a common plan. How far of a drive is that? What part of town is that in?
Montebello, I think, right?
Yeah,
I'm not
Montebello.
sure.
Oh, okay. Yeah.
Pretty far.
Yeah, depending on where your house is, that could be kind of far. That's like south, right?
Yeah.
Mm-hmm. Yeah. Okay, just a thing I thought was interesting. Are any of y'all going to take summer school this year?
Yeah, Mr. Robinson, we're thinking of taking a PCC class, like a lot of us. But the one problem is if it's going to be online or actually in school.
Oh, I basically guarantee it'll be online. I'm pretty sure PCC has already said that. Oh no, I'm thinking of the UCs. Well, a bunch of schools have already said that they'll be doing Zoom well into fall. So if they're doing Zoom into fall, they're definitely going to be doing it through the summer.
Jeez. Okay.
What classes were y'all thinking about taking?
Maybe some kind of humanities.
Or
Humanities class or
like
something.
philosophy or something.
Yeah.
Yeah, philosophy is the humanities. That's a good one to get out of the way because I guarantee it's a requisite for every single major you can imagine that you take at least one philosophy course.
Right.
So yeah, that's a good universal one to just get done. Either that or like an essay-based English course because that's a universal requirement. Anything in history will be a universal requirement. But yeah. If you have the time, you should definitely take philosophy over the summer.
Okay. Yeah, we'll see how it goes with online classes though. I mean, definitely like not preferred, but whatever, we'll see.
Yeah.
Yeah.
You got to get the credit so you can graduate. I actually have no idea what
Right.
my test is going to look like on Thursday because it's going to be from home. Like I don't know if they expect me to have my webcam on or whatever because like normally when they do this test, it's no outside resources or whatever. And if you had resources, it would greatly sway how you performed. So like if they tell me not to use anything, I won't use anything, but I just don't know how you guarantee test security for a test that is this important. That's like a you graduate or you don't thing, you know?
Wait, that's how important your test.
That's what a comprehensive exam is, brother. Yeah,
Oh,
when you have a
okay.
comprehensive exam, it is you pass this test and you graduate, or if you don't pass this test, you don't graduate. Yeah, I mean, it's not as hardcore as the bar exam because the bar exam is like organized by a governmental body, and that test is so brutal that it actually takes multiple days. But it's the same logic that like, yo, the bar exam is you pass this test, you become a lawyer. You don't pass this test, you don't become a lawyer. Yeah, it's make or break. I mean, and if you don't pass it, there is recourse. You get a chance to retake it. But like, if a test is based off of stuff that you're supposed to study for 6 years, right? It's 6 years of college all in one test. Being given an extra 2 weeks to cram, I don't think would affect your score. So yeah, I don't know what to do if I don't pass this thing, but we'll see. Anyway, let me post the homework and then we'll get out of here and then you guys can have a real nice rest of the day. And like I said, quick reminders about like the shape of the class where we're headed, and this is all on the OWS. One, there's no class on Thursday because I need to pass or fail a really hard test. And then next week, we'll have a mid-chapter quiz on Wednesday because that will take us through sections 1 through 4. And then we'll have the quiz that day. I think if this stuff is fine, you guys will find it pretty easy because the next sections are of a similar difficulty. And then after that, we'll have no class for almost a week. We'll have no class starting next week from Thursday up until the next week on Wednesday. All of that time has been blocked off so that you guys can focus on your AP tests. For every AP test that you have, I blocked off the day of and the day before so that you can go off on your own and cram or do whatever self-care you need to get ready, you know? So yeah, are there any questions on like where we're headed, shape of the class all the way through like AP test time? No?
Are we only gonna get to finish this chapter?
Yeah, this is the last chapter of the book that we'll be covering. Why?
No, I just wanted to know. Because didn't you say we were gonna do like some intro to calculus?
Oh, that's what you mean. Yeah, so with whatever time we have left after the end of chapter 11, we will do the first section of calculus, which is limits. And after the AP test, we have 1, 2, 3, 4, 5, 6, 7 more class days. And after the AP test, there's only 2 more sections of this chapter that I actually want to do. So we'll do like 2 sections, have the chapter test, which will leave us with 2 days left over. And in those last 2 days of pre-cal regular lecture, yeah, there's only 2 sections after the quiz that I care about. We'll spend the last 2 days of the class doing the intro to calculus, which is math about an idea of limits. It's basically the math that gives you the ability to divide by 0 in an intelligent way. But yeah. Anyway, you all have a real nice day. The homework is posted for 11.2. Tomorrow's workshop, so we'll have time to work on it and ask questions about it tomorrow. And I will see you on Tuesday.
See ya.
Peace.